video is on Unit 1, Chapter 1 on our algebra review, lesson number 5, operations of functions and composition of functions. So with our operations of functions, it says here you can add, subtract, multiply, and divide functions. The example that's here says if f of x is equal to 3x minus 7 and g of x is equal to 13 minus 2x, find f of x plus g of x. So think of this as just a shorthand way of telling us what to do. That statement says to take f of x and add g of x to it. So f of x is equal to 3x minus 7. So we're going to take our 3x minus 7, and we're going to add to it the g function, the g of x, which is 13 minus 2x. From here, we're adding, and what that means is we can only combine things that are alike. So you can only add or subtract like terms. Okay, so that's kind of a review from Algebra 1. The 3x matches the 2x, and you always want to make sure you look to the left of a number to tell whether it's positive or negative. And this one's a negative. So 3x plus a negative 2x is a positive 1x. And then we can add the negative 7 plus the 13. Negative 7 plus 13 is a positive 6. So we're going to write that as plus 6, and there's our answer. So in this first section, it says this new function is denoted as f plus g of x. So f plus g of x is equal to x plus 6. Now, for all operations, we can do the same kind of thing. We can add functions, we can subtract functions, we can multiply functions, and we can divide functions. So if you look in between inside the parentheses here, it's going to tell you what to do. The first one is the sum, f plus g of x. It means that you're going to take your f of x and you're going to add the g of x. With subtraction with difference, f minus g of x means take your f of x function and subtract the g of x function. Product f times, note the little dot, the closed dot right there means multiply. So f times g of x means f of x times g of x. And then the last one's division. So f divided by g of x just means you're going to take your f of x function and divide by the g of x. So this next set of examples, the directions tell you given f of x is equal to x squared minus 8x plus 4, and g of x is equal to 4x minus 3, and h of x is equal to x plus 2, find each function. Indicate any restrictions in the domain. We are going to skip that for now. We are not going to indicate any restrictions in the domain. We're not quite ready for that yet. So question number 1 says f plus g of x. So we're going to take our f function, which is x squared minus 8x plus 4, and we're going to add the g function, which is the 4x minus 3. And again, y'all, we're adding or we're subtracting on some of this, so you can only add or subtract like terms. There's not another x squared term, so I'm going to bring that down. The negative 8x can combine with the 4x. Negative 8x plus 4x is a negative 4x. And then your positive 4 plus negative 3. Positive 4 plus negative 3 is a positive 1. And there's that answer. And again, we would write that as f plus g of x. Example number 2 is a subtract. So real quick, I'm going to show you a subtract. We're going to take our f function, which is x squared minus 8x plus 4. And we are going to subtract the h function, which is your x plus 2. Now, one suggestion that I have here, anytime you see a minus sign followed by a parentheses, I would encourage you to distribute the negative. That is a negative 1. And that's going to give me x squared minus 8x plus 4 minus x minus 2. So all I did was I distributed that negative 1. Negative 1 times a positive x is negative x, and negative 1 times positive 2 is a negative 2. Now I can combine my like terms. X squared, combine the negative 8x and the negative x, which gives me a negative 9x And then the 4 minus the 2 is a positive 2. So there's our answer for example number 2. Example number 3 is a multiply. We're going to multiply the h function, which is x plus 2, times the g function, which is 4x minus 3. Now, this is going to be using distributive property again. You want to take the x times both terms in the second parentheses and the 2 times both terms in the other parentheses. So x times 4x is 4x squared. X times negative 3 is negative 3x. 2 times 4x is a positive 8x. And 2 times negative 3 is a negative 6. And then we'll combine our like terms here. There's no other x squared term. Bring down the 4x squared. You can combine your negative 3x plus your 8x to get a positive 5x. Bring down the minus 6. And there's the answer for a multiply. The last one I want to show you in this section is the divide. Number 4 says f of 8, or f divided by h of x. So we're going to take our f function and we're going to divide by the h function. And that's all I want you to do with that. Just set it up. There's nothing that we can do mathematically to simplify that or reduce that. All right, let's jump over to the next set of examples. The directions here say, given f of x is equal to 2x squared minus x minus 12, and g of x is equal to x plus 7, find each function value. So you'll notice here that instead of an x, it's got a number. So on number 7, it says f plus g, but instead of an x, it says negative 2, meaning x is equal to negative 2. That's what that means. That means that x is equal to negative 2. It's just a fancy way of writing, a different way of substituting. There's a couple of different ways we can do this. The way I'm going to show you is to just go ahead and substitute the negative 2 into the f function. And get that answer. And then substitute the negative 2 into the g function. And then our last step will be to fulfill the f plus g part of this function. All right, so g of negative 2 plus 7, that one's easy. That's a 5. I'm going to quickly grab the calculator to do the math part on this next one just for time's sake. Maybe. So we're going to do 2 times negative 2 squared minus negative 2 minus the 12. And that's going to give me negative 2. So all of that is equal to negative 2. Then to do the f plus the g of negative 2, I'm going to take this negative 2 and add the 5 to get a final answer of 3 there for that answer on number 7. You're going to do the same thing on number 8, 9, and 10. You're going to substitute the number into both functions that are listed and then perform that given operation, whether it's add, subtract, multiply, or divide. The last section for this set of notes is on compositions of functions. Another method to combine functions is called a composition. Given f of x and g of x, the composition function f of g of x is defined as f of g of x is equal to f of g of x. And it's read f of g of x. That's how we read this part right here, f of g of x. So looking at our examples, it says given f of x is equal to x cubed plus 8 and g of x is equal to x minus 1 and h of x is equal to 5x minus 3, find each function. So the biggest difference here is in between the letters, it's like an open circle. It's not a closed circle. If it's closed, little dot, that indicates multiplication. This does not indicate multiplication. What this is indicating is to substitute a function into the other function. So if you look at it here, for f of g of x, we're going to take the g function and substitute it into the f function. So in example number 11, because it says g of h of x, that means substitute the h function into the g function. So for example, your h function here is 5x minus 3. So we're going to substitute that into the g function, which is x minus 1. So in the place of the x in your g function, we're going to replace that with the 5x minus 3 and then minus 1. So if you look at the g function said x minus 1. And the way your composition of functions works is you substitute something to replace the x. So from here, 5x minus 3 minus 1 is just going to give me 5x minus 4. Let's look at example number 12. H of g of x means to substitute the g into the h. So find the g. The g is x minus 1. We're going to replace it. We're going to put that into the h function where there's an x. So instead of saying 5x minus 3, it's now going to say 5 times x minus 1 minus 3. We're going to distribute the 5, and we get 5x minus 5, bring down the minus 3. Combine your like terms, which is a negative 5 and a negative 3, and we get 5x minus 8. Let's jump down to number 15 or number 16. It says, use the same functions above, but find each function value. So this one's a little different because it is a composition of functions. On number 15, g of h of 2 means you're going to find h of 2 first. Is your first step. Once you find that, you'll substitute that answer into the g function. So let's go back to our h function up here. Let me pull this back down just a little, or up a little bit. The h function says 5 times x minus 3. So h of 2 would be 5 times 2 minus 3. 5 times 2 is 10, minus 3 is going to be 7. So h of 2 is 7. So the result is 7, and that's what's now going to get substituted into the g function. So the g function, now we want g of 7. So the g function says x minus 1. So it's going to be 7 minus 1, and that's going to give me 6 for that answer. So you tackle these a little bit differently than we did back on examples 7, 8, 9, and 10 because it's a composition of function. You find the first function, that result then gets substituted into the other function. So those are your notes for Unit 1, Chapter 1, Lesson number 5.